homework here, and we're looking at question 2 on section 7.3. And it says we're trying to figure out whether or not the triangles are similar or not. And so here is the picture that goes along with question number 2. We have triangle ABC, and we have the side lengths of 2, 3, and 4. We have another triangle over here that looks a little bigger. It's not really a right triangle. I didn't mean to draw it that way. Just a little sketch. D, we have 6, 3, and 4.5. Now, if I'm trying to test to see whether or not these triangles are similar, and I have just side measurements, we're going to try to look at the side version, correct? We have 3 options to choose whether triangles are similar. And if I only have side measures, then side is our choice, which means that we're going to look at this extended proportion, okay? We're going to go small to small. So 2 in the left-hand triangle, or the small triangle, is the smallest side. What's the smallest side over here? So that's those correspond to each other. Small goes to small. So we have 2 is to 3, and then we'll do the same thing with medium. So 3 is the medium side length. What's the medium side length on the other one? 4.5, okay, 4.5. So we'll say 3 is to 4.5, and then the remaining is 4 is to 6. Now, how do I test to see whether or not those are the same ratio? Well, you would use a calculator, and you're going to simply divide. What is 2 divided by 3? 0.6 repeating, and Maddie's going to type in the other ones. So I have 0.6 repeating here, and then I want you to type in 3 divided by 4.5 for me. And we get the same thing, and then go ahead and do 4 divided by 6. And the same thing. Since they all reduce to be the same ratio, all the sides are proportional, right? Which means by side, this is true. What is the scale factor from the left-hand triangle to the right-hand triangle? 2 to 3. It's 2 to 3. 2 to 3. Okay, so this actually gives us the scale factor if you go in order from left to right. Okay? Any other questions on 1 through 12? If I scroll down a little bit, 13 was the proof, right? You want to look at the proof? Can you do 7? Sure, I'll come back and do 7. I know I want to do 26. Because 26, 25, and 24 were all very similar. They ended up being quadratic. Okay? And 4 of you guys got that, which was awesome. So we're going to look at question 26. But you said, I'm sorry, 7? Okay, let's look at 7. If we look at question 7. 7 says, determine whether the triangles are similar. If so, write the similarity statement and why. So this picture, we have some parallel lines, and we know a lot about parallel lines because we know that corresponding angles are congruent. We know that alternate interior angles are congruent. Which case do I have here? Alternate interior or corresponding? Alternate interior, which means F and K are congruent. I also know that G and J are congruent. And then don't I also know that the vertical angles are congruent? Okay, so I have angle, angle, angle. I only need angle, angle, but I have all 3. So by angle, angle, I know that triangle FGH is similar, and we have to write it in corresponding order. This is your similarity statement. What does F correspond to in the other triangle? K, so it's going to be K, J, H. And again, you could write this in any order as long as F corresponded to K, G corresponded to J, and H corresponded to H. Okay? Number 1? Number 1, if you actually just look at this one here and you figure out the missing angle, that's 100. And if you go, no, yeah, you just find the missing angles. Okay? All right, so did you guys want to go over the proof, or did the proof seem reasonable to you? We had reflexive property because they shared an angle. By angle, angle. You guys tell me. How many steps was that proof anyway? I think it was just 3. Did you guys have any issues with it? It's just given, reflexive, done, right? Okay, we won't go over it then. So we just want to look at question 26. Is that correct? Okay, so let's definitely look at, oh, did too much. Question 26. Where is, oh, sugar. Look at me. All right, it's up here. There we go. right, 26. Bless you. Okay, so what I'd like to do in this problem is first determine whether or not triangles are similar. Okay, so do we have a pair of similar triangles? Yes or no? What's the reason that they're similar? Well, maybe it's better if I separate them. I have a little triangle, or I have a 10 and an x plus 2. And then I have a big triangle. Would you agree? Where I have an x plus 14 and a, what's the length of the left-hand side of the big triangle? What is it? X plus 10 or 10 plus x, however you want to say that. So x plus 10, you're adding those, right? Well, are these triangles similar? Well, what angle do they both share? Don't they both share that top angle? So we can mark that on both of the pictures. What else do we know about the triangles? We have parallel lines. That means something. Jonathan? Perfect. I've got corresponding angles here and here. I also have them on the left-hand side, however you want to do it. So are the triangles similar? What's the reason? Angle, angle. Okay, so I know they're similar. If the triangles are similar, aren't the sides proportional? So what we need to do is write a proportion, and that's what we're going to do. We're going to say that 10 is going to correspond to what on the left-hand side? On the right-hand side. 10 corresponds to x plus 10. Good. And then we will have that x plus 2 corresponds to x plus 14. And as I looked at your homework when you brought it up, it did look like most of you got that far. Okay, we can write the proportion. It's solving it that becomes algebraic, very algebraic. And do you remember how to solve this? And I told you, because you guys are all going to MYP Algebra 2 next year, or Algebra 2 Treg, that you really need to remember this kind of stuff. So I'm going to interject algebra throughout the year. This is one of those cases. Okay? So when I cross multiply this, let's start with the left-hand side. Let's do the extremes. I'm going to say 10 times x plus 14. And then if I go ahead and multiply the extremes now on the other side, notice I have to put parentheses. I have x plus 10 and x plus 2. I put the parentheses there because these are two binomials that I'm multiplying together. And I need to remember how to do that. Let's start with the left-hand side. What do I do with the 10? Distribute it. Love it. You remember the property. So when I distribute the 10, I get 10x plus 140. What do I get on the right-hand side? Who remembers how to multiply that? Go ahead, Lucia.
You multiply the x with the x.
Okay. Well, okay. Good.
Then you multiply that x with the 2.
Good.
That
So it's like distributing. You're distributing both the x and the 10 to the other pieces. Some teachers might have taught it to you using the acronym FOIL. Okay, either one is fine. So 10 times x and 10 times 2. So I have 10x and I have 20. All I'm doing is multiplying. That's all I've done. What kind of equation is this? Begins with a Q. Say it louder, Marvin. It's quadratic. So I have to remember. Now, I love when I looked at your homework because Andrea did guess and check. Awesome. Julian did a quadratic formula. Awesome. Lucia factored it. All three are correct. Okay? Now, what's the proper algebraic way? Probably either quadratic formula or factoring. But hey, it worked. She did what she was supposed to do. How do I guess and check, or how do I even get it to the point where I can factor it or where I can use a quadratic formula? I got to get everything to one side. I have to get it equal to 0. Should I move everything to the right side, or should I move everything to the left side? Either one is okay, but one is preferable because if I moved everything to the left, what would happen to my leading coefficient? It would be what? It would be negative, which makes it kind of hard to factor. It's okay to use a quadratic formula, though, but you've got negatives to deal with. I think it might be preferable to move everything to the right, therefore I don't have to worry about that negative in the front. So that's what I'm going to do. I'm going to move we have 12x minus 10x. Is that too hard if I do that too many steps at one time? I'm just moving the 10x over here and combining it with the x's that are already there. Then I'm going to subtract the 140, so I get minus 120 equals 0. Now, I kind of skipped a little bit. That's all algebra stuff. Any questions so far? Now, at this point, Julian said, okay, I'm just going to go ahead and do the quadratic formula. Perfect. I'm like so ecstatic that you remembered even to do that and knew what that was. That's awesome. And then Lucia is a factoring goddess, so we're good, okay? But how do we remember how to factor? I think that it is factorable, so it's quick to do it that way. The two numbers have to multiply to be negative 120, and they add to be 2. Okay? So what would that be? Negative 10 and positive 12. Isn't that the correct factoring of that? Now, if I wanted to solve it from this point, once it's equal to 0, I'm going to take each factor and I'm going to set it equal to 0. My first answer is negative 12. My second answer is positive 10. How do I know this one makes no sense? I can't have a negative measurement. Isn't x a length? So I can't have a negative measurement. So the only correct answer that makes sense in this case is 10. Okay? Now again, most of us could set the proportion up correctly. Okay, good on you. That's awesome. But we got to remember algebraically what to do. Okay? Do you think you can go back and look at the other ones and try it again? Okay? Here's what I'm going to do. I'm going to let either question 20, I don't think 24. I'm going to let question 25, if you can show me the work on a separate piece of paper, it'll be extra credit and count as a homework pass. Okay? So, not right now, but you can show it to me next class. So question 25 on a separate piece of paper, so if you've already done it and you knew how to do it, you're great. But just write for a homework pass and you can turn it in next class. It's like a challenge problem. Fair enough? There's extra practice to learn how to do this, or to remind ourselves how to do this. So again, question number 25 for a homework pass, next class. Show me all the steps, either quadratic formula or factoring. I think that one works that way too, does it not? Those of you who did it? Yeah. It's also a factoring one too, right? Yeah, okay, which is a little harder to factor. Okay, so again, why it's a homework pass problem. Quadratic formula makes it okay. All right. How do you feel? Okay? Proportions okay? Better? Go on. You're looking at me like, oh. You okay? All right. What we're going to look at today, and I hope you brought your coat, hope you got my text, hopefully you knew to bring one, because we are going to go outside in a couple of minutes. We're going to go measure the height of the flagpole, which will be kind of interesting, using mirrors. But I wanted to do an example here first, okay? So I'm going to turn the lights down because I think that's really hard to read. And we're going to look at this problem and kind of discuss it for a minute, and then we'll decide, okay? So read this question for me, and then we're going to look at it. Before we answer the question, why is it important for the ground to be flat, okay? Let's actually look at the problem itself and make sure we understand what's happening. And this is what we're going to do. You're going to partner up with somebody, and I'm going to partner you up if you can't find a partner. Hopefully we have enough, everybody, to have one. And you're going to find the measurement of several heights around the school. You're going to do the height of the tallest peak in the school, a lamp post out front. I don't know if we can do a lamp post. I'll have to look because the buses are going to be here. You'll be in the bus lane, which they'll get all angry at, and then I'll get in trouble, and you'll get hurt, and then I'll get sued, and then I'll lose my job, and it'll be terrible. So probably just the flagpole, but we'll figure that out. Flagpole is essential, so you have to do that because we're going to actually find the height of the flagpole this year 2 different ways, and you're going to compare them. So you have to do the flagpole first, okay? Anyway, this is a person, Darius, down here, and he's trying to figure out how high this rock is that he wants to climb. And so I kind of drew, or I didn't draw, but the picture shows 2 triangles. And there's a mirror on the ground. And we call that the angle of incidence versus the angle of reflection. You may or may not have heard that in science. Okay, well, science is real. Okay, we use it in math, or math is. So we have an angle of incidence and the angle of reflection. They happen to be congruent angles, by the way. Okay? I also, and I'm assuming that Darius is not a hunchback, okay, that he is standing up tall and he's straight, so he's going to be perpendicular to the ground. And we're going to be looking at our cliff, and the height, altitude, height is always a perpendicular distance, correct? So do I have similar triangles here? What's the reason the triangles are similar? Side, 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 angle, side, or angle, angle? I don't know anything about sides yet. I know angle, angle, though. So I know they're similar. Because they're similar, I'm going to use the ratio of the sides, though. So I know they're similar by angle, angle. Great. We're going to measure how tall we are, okay? And we probably do that when we get back in the room. But I'm going to say that this guy, Darius, is 5.5 feet tall, okay? 5 feet 6 inches. Okay, we're going to actually convert everything into one unit of measure. He said 5.5. That's fine. So we're just going to stay with feet in this case. Okay. So can I write a ratio? Well, first of all, what are you measuring here? Aren't I measuring from Darius to the mirror? And you can't read it, but it says 6 feet under here. This says 6, and this says 5.5. Okay. You good? And this is hard to read, but this says 34. And we're trying to figure out how tall this is. So if you're going to measure with a partner, okay, you're going to have to decide between you and your partner who's going to be doing the Darius, who's going to be standing tall, and who's going to be measuring from the person to the mirror, and again from the mirror to the bottom of the object, or in our case, the bottom of the flagpole. Yes, sir. That is an excellent question. So we have these little mirrors, and we got new ones last year. We're trying to figure out, because the ones we had before you couldn't even see. So we have these little mirrors here, and they're brand new, haven't even been used, which is kind of exciting. They're not glass, so you're not going to break them. They're shatterproof. Okay, and they're two-sided, and you're going to put them, they might even have, I think they have plastic on them, I think. I don't know. You can decide that for yourself. But anyway, where do you know where to put this? Okay? What you're going to have to do is a little bit of guess and check. You don't want it right up against the flagpole. You want there to be some space. Okay? Now, depending on where you put the mirror, the distance, you may have to walk back from the mirror or walk closer towards the mirror. So you want to just basically put the mirror somewhere between yourself who's standing and the object you're trying to measure the height of. So let's practice for a minute. Let's say I want to find the height of my door, okay? So I'm just trying to find something where I have a clear path to. Does that make sense? So I'm going to put the mirror somewhere, and Daniela's going to try. Come on. Okay? I'm going to put this somewhere in between, and what you're going to be looking for is like a tip. So in the flagpole, you're looking for the tip top of the flagpole, okay? So you're going to be looking in the mirror for, should we say the Chihuahua's face? I don't know. That's not the height of the door, but maybe the, I don't know, that corner, okay? So you might have to walk a little bit further back, I would think, and keep walking. Do you see anything in the mirror?
The corner.
You do see the corner of the door right there, okay? Now be careful. Do you see how her head's pointing down? Why is that not a good idea? Because your height will be different. When you measure your height, am I measuring to the top of my head? I have eyes on the top of my head? Where am I going to measure to? The height to my eyes. So when we get back into the room, I'm going to tape up a measuring tape, and you're going to measure to your eye height. You can look like this, and you can figure, I'm going to put a tape here, and you're going to measure, oh, I am this many inches tall. Okay? So now, she's going to stand there. I may or may not, because the flagpole is a big distance. Do you agree? I mean, this one, for God's sakes, is 34 feet long. Don't move, don't move, don't move. I don't have a 34-foot tape measure, guys. What am I going to do? Well, I'm going to measure it with my foot. Okay? Because let me see. Could I measure my foot? Could I measure the distance of my foot, like the length of it? I don't know however many inches my foot happens to be. And then if I say, okay, I'm going to measure from Daniela to the mirror, I'm going to go like this. So don't move. I'm going to go from toe, I'm going to go one in front of the other. Now, I want to walk as straight as possible. Do you agree? I don't want to be rocking all crooked to the mirror. You want a straight distance. And we really want to go to the middle of the mirror. So I probably would say, what did I do, 3.5 feet? I don't know. Did you even count? You're not even paying attention. Okay. Then I'm going to go from here all the way to the bottom of my object, and I'm going to count. Okay? Understand? Thank you, sweetheart, for demonstrating. Are we clear with where the mirror goes? You may have to back up and go forward a little bit. You can't bend over. You got to kind of like do this action. Okay? We good? Let's solve this problem on the board, though. Let's figure out how high this rock is, or this cliff is. Once I know the height of his eyes, how far from the person to the mirror, from the mirror to the object, how can I write a proportion to solve to figure out the height of the rock? Well, what corresponds to what? Doesn't 5.5 correspond to what I'm looking for? And doesn't 6 correspond to 34? Could I cross multiply and solve for this point? And that's what you're going to do. Okay? Any questions? Okay, so a couple things we need to do is, one, you've got to partner up. So why don't you go ahead and get your partner. Once you've got your partner, you are going to have to measure your foot. I would like for you to measure it in centimeters. I think centimeters is the easiest thing to use. I do have some centimeter rulers up here. Only the person that's doing the measuring, doing the actual walking, needs to measure their feet, right? The person who is standing and looking at the mirror needs to measure what? The height to their eyes. So I'm going to put up a height ruler over here for you guys to do your measuring. So partner up. You need one of these per person. You're both going to fill one out. I'm going to put them here in front of Maddie. And each group needs a mirror. The first kind of, we call this indirect measurement, because you're not actually taking a measuring stick or a tape and measuring the height of the flagpole or the light pole like we just did. You're actually indirectly measuring it using your feet and a mirror. This is another example of indirect measurement. So let's look at this example. It says Benjamin wants to measure the height of an oak tree. So I'm going to draw a picture, and I'm going to draw an oak tree. Don't laugh at my drawings. Okay? And it says at a particular time, this tree has a shadow of, well, when we have shadows, we know that we have we have a sun, right? Which means that its shadow is, how long was it? 13 feet long, from here to here. You agree so far? At the same time, here is Benjamin. He's 5 feet 8 inches tall. Okay? And so he's 5 feet 8 inches. I'm just going to write it that way. 5 feet 8 inches. We'll convert all to 1 unit eventually, okay? And his shadow was 3 feet long. You good on me so far? We could draw them as separate triangles if we wanted. We had the big one, we had the little one, where we had this is 3, this was 13. We're trying to find the height of the tree, aren't we? And then this was 5 feet 8 inches. Now, before I continue this problem, I would have to convert everything to 1 unit. Would you agree? Everything to inches or everything to feet. I don't really care. Probably inches, I guess, just because then we wouldn't have fractions. So 5 feet 8 inches is 68 inches, correct? Because there's 12 inches in a foot. And then 3 feet would be 36 inches. What's 13 times 12? Y'all have calculators?
Oh, Maddie, go. What is it?
13 times 12. Thank you. So everything's in terms of inches now. Would you agree? Could I set this up to solve? So what would the proportion be here? 68 is to x as 36 is to 156. When I cross multiply 156 times 68, I got 10,608. Let's divide that by 36. Thank you. Oh, okay. So that's the number of inches. Okay, well, we don't really measure trees in inches, do we? We really measure them in what? Feet. So can you divide that by 12 again?
Oh wait,
That's okay.
the answer mark?
Yeah, write that. So it's 24 feet tall. Okay, so I have, wait, it was 294.6 repeating. And if we divide that by 12, we have 24.5 repeating. So I have 24 feet. How many inches is 0.5555555? How'd you get that? Not exactly 6, but it's close to 6 because it's half a foot. Would you agree? So to the nearest inch, be 24 feet, 5 inches. Okay? Yes? Is that okay? Notice the picture is a little bit different because when we're talking about a shadow, notice the direction of the picture. When we're talking about a mirror, there's a reflection issue. Do you see that? There's a little bit of a different picture that's drawn. So you'll have one in your homework that's a shadow problem and a reflection problem. They're both there. I just wanted to make sure that I showed you this one before you got your homework assignment. You are also going to have some geometric mean and right triangle questions kind of mixed in there together. I'll write your homework up here, but in the meantime, y'all can finish the flagpole assignment, okay? Give me 1 second, sweet please. I'm sorry.